Good evening. In this video, we're going to start to explore book 3 from the Elements written by Euclid. And the topic of this book will be some beautiful properties of circles. Okay, so at the beginning of this book, Euclid had introduced 11 brand new definitions, and let's cover them one by one in this video. Okay, so first of all, let's talk about definition 1 from book 3. So this definition talks about equal circles. So equal circles are those whose diameters are equal or whose radii are equal. So for example, we have two circles, and let's say these two diameters d1 and d2 are equal, then these two circles are equal. And or let's say those two radii are equal, say r1 is equal to r2, and then these two circles are defined as equal circles. Okay, so that's definition 1. And we would like to put definition 2 and 3 together because they are talking about the relationship of touching. Okay, so definition 2 says that a straight line is said to touch a circle which meeting the circle, and if being produced, it will never cut the circle. So for example, we have a straight line here, L, and a circle O here, and it is said to touch the circle, for example, at the point of T, if we, let's say, produce this straight line in either direction, and it will never cut the circle. Let's say, for example, we have another straight line L prime here, and obviously they are meeting at the point here, P1. But if we produce L prime in this direction, it will cut this circle O at another point, for example, B2. So this is not touching. So L is touching the point O, sorry, the circle O as a point of T. Okay. So in another expression, we can say that the straight line L is tangent to the circle O as a point T. Okay, that's definition 2. And definition 3 says that circles are said to touch one another, which meet one another but do not cut one another. So, for example, circle O1 and circle O are touching as a point of T. They have only one touching point, and they are not cut one another. Let's say, for example, we have another circle here, circle O3, and it intersects circle O at 2 points. So this is not so-called touching. So if two circles are touching one another, they have only one touching point, or let's say they meet at only one point. And similarly, circle O2 and circle O are touching at point T2. And in another expression, we can say that circle O1 and circle O are internally, remember, internally tangent at point T1, and meanwhile circle O2 and O are externally tangent at point T2. So this is externally tangent, and they are internally tangent. Okay, so that's definition 3. And let's go to definition 4 and 5. We put them together again. So definition 4 says that straight lines in a circle are said to be equally distant from the center when the perpendiculars drawn to them from the center are equal. So let's say we have two straight lines L1 and L2 in the circle O, correct? And we have two perpendiculars that are perpendicular to them respectively from the center O, and we say that H1 is equal to H2, then these two straight lines L1 and L2 are said to be equally distant from the center O. Okay, pretty straightforward definition. And definition 5 is an extension, I believe. So it says that straight line is said to be at a greater distance on which the greater perpendicular falls. Okay, so let's say we have another straight line L, and H is a perpendicular drawn from L through the point O of O, which is the center of the circle. So H is greater than H1, okay? So it is defined as the straight line L is at a greater distance, greater than L1 and L2 to the center of the circle O, okay? So let's move to definition 6 to definition 9 together. Okay, so definition 6 defines a segment. So a segment of a circle is a figure contained by a straight line, for example, AB, and the circumference of a circle. So let's say we have a straight line AB in a circle O here, and the circumference ACB, and we can see the shaded area is the definition of a segment. This figure is a segment. But please pay attention that at the other side, this side, ADB is also the circumference, and the ADB, the circumference together with AB, they are surrounding another segment of the circle. Okay, so ADB is also a segment. This is definition 6, and definition 7 talks about an angle of a segment. It is that contained by the straight line AB, for example, and a circumference of the circle. So for example, we have AB, the straight line, and ADB, the circumference, and angle alpha is the so-called angle of a segment. It is contained by ADB, the circumference, and AB together. But please pay attention that angle alpha is not a rectilinear angle, okay? Because ADB is absolutely an arc of the circle, and it is curved rather than straight, okay? And angle 8 declares that an angle in a segment. Please pay attention, it is angle in a segment, and it's not off. They are different, very similar words, but different concepts as all. So definition says that an angle in a segment here, like beta, is when a point is taken on the circumference of the segment. So for example, we randomly take point E here on the circumference ADB here, and the straight lines are joined from the extremities of the straight line, which is A and B, together with a randomly taken point E here. So which means we are joining AE and BE respectively, and the angle in a segment is defined as the angle here contained by those two straight lines we have just drawn, okay? So this is a rectilinear angle, okay? It is contained by two straight lines. And definition 9 is just another expression of the angle in a segment. So it says when the straight lines containing the angle cut off its circumference, the angle is set to stand upon the circumference. So let's, for example, take some of your imagination. So this is the angle beta, and it stands upon the circumference here, ACB. Let's say if we rotate this image upside down and make this shaded area downside, and this angle will be somewhere like here, and we imagine, let's imagine this is a person, and this shaded area is a base, and it looks like it is standing upon the circumference, upon the base ACB. So that's definition 9, okay? And let's move to the last two definitions. So definition 10 declares another concept of figure. It says, which is called a sector, okay? So it says a sector of a circle is a figure when an angle is constructed at the center of the circle. For example, this is the center of the circle O, and we constructed a rectilinear angle, OB and OA together. This is the angle, and it cut off the circumference here, AB, and the figure surrounded by the circumference AB, the cutoff circumference AB, and the rectilinear angle from the center of the circle here, surrounded by them. The figure is defined as the sector of a circle. Okay, so this is a sector. And let's move to the last definition from book 3, which is definition 11. Definition 11 defines similar segments. So remember what segment is, okay? We have just defined it. This is the segment. So definition 11 says that those two segments admit equal angles, or let's say in which the angles are equal one another. So it defines like this. For example, this is a segment ACB, and this is another segment A prime, C prime, B prime. And if these two angles ACB is equal to angle A prime, C prime, B prime, correct? And we say these two segments are similar. Okay, that's definition 11. So we have covered 11 brand new definitions introduced by Euclid from book 3. And that is the end of the video. And in the next video, we are going to talk about those, I believe, more than 30 propositions from book 3 one by one. Okay, so thanks for watching. Have a good day.